now talk the conservation of energy. Conservation of energy is when there is no force present, the total potential and kinetic energy is constant, so there is no added energy to the system. So, conservation of energy, wala yung air resistance and other force, tsaka yung sum ng potential and kinetic energies are constant. So, the formula for that is mg h sub 1 plus 1 half k x sub 1 squared plus 1 half mv sub 1 squared is equal to mg h sub 2 plus 1 half k x sub 2 squared plus 1 half mv sub 2 squared. Mahaba, pero that's important. Okay. Next, while mechanical energy refers to the total kinetic energy and potential energy of the system. So how will we gonna solve for the mechanical energy? Mechanical energy is equal to kinetic plus potential energy, which is constant according to the conservation of energy. So the following are the problem solving strategy that may help you solving problems. So number 1 is of course read and understand the problem to be able, if possible, draw the sketch and identify the given. Number 2 is to determine the reference point using the GPE, gravitational potential energy, such as the bottom on an inclined, floors or the lowest point. Number 3, put labels. Mahirap na yung walang label on the initial and final position and the velocities such as those from the reference point. Next, so number 4 is the conservation of energy. That's so helpful. Number 5 is important to fully solve the problem. You need to determine whether or not friction force are present. If friction or air resistance is present, then the energy losses must be given or determined. Isn't it sa conservation of energy, there should be no forces present. So kung meron, the energy losses must be given or determined. Often, the energy loss in doing work against friction is the simplest product of the friction force and the displacement. So remember this formula. F sub k is equal to constant kinetic energy multiplied by n. Next, number 6 is the conservation energy formula again. And solve for the unknown. It is useful. Number 7, use absolute value of energy loss when applying conservation of energy. It is because you are referring to loss and not against the friction. So you're going to you're going to use absolute value. Absolute value is yung dalawang line straight, which a negative will become positive. So problem number 8 is so easy. A 20 kg lead rests at the top of 30 degrees slope, 80 meter in height. If our constant kinetic energy is 0.2, what is the velocity at the bottom of the incline? So we're looking for the velocity. Let us solve the problem by first the given. So our given here is the mass, which is 20 kilograms, our displacement, which is 80 meters, our constant kinetic energy is 0.2, our height is 0 meter, our p sub 1 is 0 meter per second, our theta is 30 degrees. So we're looking for the velocity at the bottom of the incline. So we know we will use the conservation of energy formula. I will not read it because it's so mahaba. Substitution, but we need first to solve for the h sub 1. That would be 80 meter is equal to sine 30 degrees. So our height would be 40 meters. Next, we will solve for the f sub k, but in order to solve for f sub k, we need to have our n, and n is equal to h sub y, and the formula there is mg cos theta. Substitution, 20 kilogram multiplied by 9.8 meter per second squared multiplied by cos 30 degrees. That will be 170 Newton. That's from the end. But our formula for F sub k is the constant kinetic energy multiplied by n. Our constant kinetic energy is 0.2 multiplied by 170 Newton. That would be 34 Newton. So we have our F sub k there. Substitution to the original formulas above formula. So substitution. I'm not gonna read it again. Maawa na ako sa boses ko. So 1/2 we're looking for the velocity, that's why we're looking for the v sub 2, the velocity. So v sub 2 is equal to the square root of 5,120 joules over 10 kilogram. That would be 22.6 meter per second. That will be the velocity at the bottom of the incline. This is our references. Thank you for listening. See you in the next lesson.